8-61, we are solving some inequalities with absolute value. They're going to be done really pretty much the same. The only difference between them is there's a 2 out front for problem B. But for both problems, what I want to do is I want to get the absolute value here by itself. There's a couple things also to think about. Normally when we talk about this in class, I say we're going to switch this inequality to an equal symbol. And when we set that to an equal symbol, then what we're doing is we're finding the boundary points. We're finding out when it actually is equal to 5. And then from there, we can go through and test some points to figure out when the inequality, in this case, the less than, works out. So if I want to figure out when this right here, 2x plus 1, the absolute value, that equals 5, there are a couple things we need to take into consideration. First of all, if I just think of something being inside of here, the absolute value of some value equals 5, there are 2 options. The absolute value of 5 equals 5, and the absolute value of negative 5 equals 5. So whatever is inside of here, inside of the absolute value, can have 2 possibilities. It either can be 5 or it can be negative 5. So that's what sets us up here for this next part. So now, when I look at my 2 equations, I'm going to get 2x plus 1 equals 5, because I want to know the value of x that makes it equal 5. And I have 2x plus 1 equals negative 5. So again, the value of x that makes this true and this true. So for both of them are going to be solved the same way. I'm going to subtract 1 from both sides on both problems. So I'm going to get 2x equals 4, and dividing, and I get x equals 2. On this one, I get 2x equals negative 6, and then when I divide, I get x equals negative 3. Those are the boundary points, which means when I'm looking at my answers to this, on a number line, I have negative 3 here, I have a positive 2. With this symbol, it is not or equal to, which means we want to have open circles on both of those, because it's not going to include the boundary points. I now have 3 areas to check. The options we have here is either they're going to go on the outside, or your answer will be in between. It will never be something like going this way forever, both these. If that ends up happening, that means my boundary points are wrong. So I can check a number over here, I can check a number in between, and I can check a number over here. A really easy number to check right away is 0. And in this case, 0 is between. So if I check 0, and I put 0 into my inequality. So again, I'm going to switch this back now to the inequality. If I put 0 in for x, I get 2 times 0 plus 1. So the absolute value of 1 is that less than 5, and the absolute value is 1 is 1. So I have 1 is less than 5. That is true. If that's true, that means 0, which would be right around here, is a solution to this. And since it's between there, that is where I would shade. If I would go through and check something just to make sure that I didn't make a mistake, if I check something on the outside, so let's say I go through and check a value like negative 5 over there. So let me put in negative 5 right here. Instead of this being 0, let's put in a negative 5. Now I have negative 10 plus 1, which is going to be the absolute value of negative 9. Is that less than 5? Well, the absolute value of negative 9 is less than 5. That is not true, which means I do not shade to the left of negative 3. The same thing should happen if I would check a number over here. It would have given me an inequality that would not work. So now my answer to this problem is going to be negative 3 is less than x, which is less than 2. I'm going to go through problem B a bit quicker just because I really wanted to build up kind of the knowledge of why things are happening for problem A. So for problem B, the first step I want to do is get rid of that 2 so it looks just like this problem and I have the absolute value by itself. So if I divide both sides by 2, I'm going to get the absolute value of 3x minus 2 equals, and again I made it into an equal symbol, 5. So now I get my two equations. 3x minus 2 equals 5, and 3x minus 2 equals a negative 5. Adding the 2, 3x equals 7, x equals 7/3, and 3x equals negative 3, and x equals a negative 1. So those are my boundary points. So now if I take a look at my line here, negative 1 and 7/3. I have an or equal to symbol, so it's going to be a closed circle on each of those. I'm going to again test values. I'm going to test 0, which 0 would be in here. So when I put 0 in right here, I get 3 times 0 minus 2 is going to be negative 2. Absolute value of negative 2, is that greater than or equal to 5? I just used this equation here, or inequality, by the way, instead of going back to the original. That is going to be 2 is greater than or equal to 5. That is not true, so 0 does not work. So my answer should be out here and out here. I'm just going to double check. I'm going to pick a value on one of those sides. So I'm going to pick a value over here, and it could be anything over there. I'm going to try the value of 10. 10's a good number. It's far away. So now I'm going to multiply that by 10. So now I have 30 minus 2, which is going to be 28. Absolute value of 28. Is that greater than or equal to 10? And that is true. 28 is greater than or equal to 10. So my value over here worked out. So my answer is that way. The same will happen if I check over there. So now my inequality that I have to write is a little bit different. This is now an or inequality, because my answers are here. So x is less than or equal to negative 1. Or my answers are over here. X is greater than or equal to 7/3.